All right, well, we're right here now at 12 noon, and thanks to those of you who are joining us, both here on the Zoom application, as well as those of you that are viewing us over the Facebook connection. This will also be on the LiDAR Pros YouTube page shortly after this particular Lunch and Learn is underway. My name is Douglas Spotted Eagle with the LiDAR Pros, and we're going to get through some mapping tips and techniques, so we're going to dive right into it. Let's get started. So when we're mapping, there's some things that we absolutely want to be focused on. We definitely want to have precision on our job site, and that precision can be achieved a number of different ways. We're going to talk about that in just a moment. Automation is a key feature of having a successful mapping application, and there are some good automation tools, and there are some kind of weak automation tools. We'll talk about those here. One of the most important things is that we've got pilots that are risk averse. People that understand decisions that need to be made and make safe and intelligent decisions. I'll give you an example real quickly what I'm talking about. Not too long ago, one of the people that work within our circle were doing a fairly large survey on some ground, and the area contained a water tank. Well, rather than doing what we probably would have done and put up a scouting drone to ascertain the exact height or very close height of that water tank, this particular organization chose to not do that. They had a pilot that said, well, I think that water tank is about 65 feet in altitude or in elevation, so we're going to go ahead and set our flight altitude at 75 feet. We should be fine. Well, unfortunately, it didn't work out that way, and that particular company ended up crashing a nearly $100,000 asset with a LiDAR sensor system on it. So we want you to be thinking about what is safe, what is practical, what is practicable, what is applicable. And there's not a whole lot of limitations to what we do, but as I've just illustrated with the crash question, sometimes our outcomes are very, very harsh. So what are some of the challenges that we can run into mapping, especially if we're operating in urban environments? Well, we can certainly run into wind tunnels, or in other words, wind that has high velocity moving through urban canyons, in other words, between buildings and so forth. Sometimes we're going to run into RF interference when we're dealing with certain types of construction materials. For example, if the building that you're working around has got an all-steel skeleton, well, it's quite possible that there could be a problem there, and we could run into some RF interference because of that information that RF information that's bouncing around out there. It can also impact what we call multipathing, where the satellite signal comes down from space, hits something steel or something metal, and bounces it around in the environment. And that means that our drone, our UAS, is receiving instruction from the satellite system about its positioning, but it's late. Now, that's generally not a real big deal for us unless we're in an area that's got a lot of magnetic interference, or we might even have some other kinds of interference that are out there, some EMI, etc. But it's something to be aware of. We also have some regulatory confinements, depending on where LANCE allows you to fly or what your minimum altitudes are going to be in the facility maps. That can come into play to be a little bit of a problem for us as well. And then, of course, we always have things like challenges when we're dealing with the altitudes, and it might be that we've got cranes in the area, we might have wires in the area, we might have other construction equipment, and of course we might be proximate to other structures as well. Some of the other challenges is flying over people. We want to be sure when we're mapping on a construction site or on a job site that we are not flying over persons. Now, bear in mind, if that job site is a closed job site, it's quite likely that your aircraft will fall into what's called a Category 3 flight over people operation, and you'll just need a declaration of compliance that demonstrates that your drone is capable of delivering less than 25 foot-pounds of kinetic energy on impact, and that you've got remote ID enabled per Part 89. Do your clients need remote viewing? In some cases, clients want to see the map as it's being developed, or see the job site as it's being mapped through live transmission of data. This is pretty easy to do today. There's a number of different ways that it can be done with HDMI broadcast systems that we can plug into, such as Live Views, and just straight plug into Zoom via HDMI is a great way to be able to share this data. Sometimes we run into challenges where we're dealing specifically with LiDAR, particularly with LiDAR, where the IMU systems in some of these LiDAR packages will not work with various software packages. So we want to be sure that we're working with sensors and software packages that are really compatible. If you're a drone service provider, a field service provider out there, That can run into a little bit of challenge if you've got a particular drone system and your client's got a different software system. These are just conversations that need to be had, and they're generally fairly readily put off to the side. Be aware that if you're operating out in the field, it's a good idea to have your basic safety PPE on. In other words, we want to have that kind of thing. But what I've written vested operators here for is what I mean is by that isn't what we wear. What I mean by that is how we think. Are we vested in having the best map out there, or is it just simply that we walk out, identify a region, and begin flight without paying a whole lot of attention to some of the factors we're about to discuss? We also want to be aware of any reflective surfaces if we're flying in with LiDAR or if we're dealing with oblique photogrammetry. So if you've got a building that's got lots of mirrored surfaces, we're going to want to fly and identify angles that will work well for us. If we're flying a LiDAR system, we've got to collect shiny things like bumpers on cars. We're probably going to want to use some dulling sprays or different things like that, particularly if it's a forensic capture. If we're dealing with wet ground and LiDAR, probably best to wait for it to dry out. Another thing that we want to be thinking about as we're setting up our mapping or going into planning for our mapping is what ground sampling distance, or what we call GSD, do we really need to have? Of course, a lower GSD is always better, especially when we're dealing with low resolution cameras, such as the very common 1-inch cameras that we find on things like the DJI Phantom 4, the Autel Evo 2 Pro, and some of these other 1-inch camera sensors that are out there. It's a good idea to try to see if we can achieve somewhere between half a centimeter per pixel all the way out to 2 centimeters per pixel. Anything higher than that in a low resolution camera format, such as these 20 megapixel 1-inch cameras, we can run into some challenges unless we're just doing gross work and we're not worried about getting down to our 0.2 of a point in accuracy, or a centimeter of accuracy. So think about what that ground sampling distance really means. Why is this important? Because the lower we go in ground sampling distance, in other words, the better sample we achieve, the lower we have to fly our aircraft. The lower we fly our aircraft means the longer our flight time is going to be. So there's a balancing act between that conversation of GSD, or ground sampling distance, and altitude and efficiency of our overall flight. So bear in mind that the timing is always, or the amount of time that's going to be vested is going to be a pretty big consideration. Imagine that the horror, for example, if you floated a quote out there to a client or to your boss, said, hey, I'm going to fly this at 400 feet, and it's only going to take 15, 20 minutes to fly this. And then all of a sudden your VDC or your engineers come back and say, well, we really need that flown at a GSD of, say, half a centimeter per pixel. That's going to drop your drone down to 400 feet, or from 400 feet down to 100 feet. And all of a sudden we've increased our flight time by a factor of at least 4. So just something to bear in mind. What do we really need to have for our ground sampling distance? What are some of the other things that can occur, challenges that can occur in mapping? Well, what you see before you here is a map of a corridor. This street is not bent, and no, it doesn't have an unusual curvature against the earth. What this is a map that was created, or a model that was created without tying anything to the ground. In other words, the drone was just flown. There were some problems in the way that it was set up, and we're seeing the images all captured correctly, but there's nothing that's being tied to Earth. So we've got some things that go below horizons. So how do we make that not happen? Well, there's a few different ways to do it, but the best way to do it, particularly if we're looking for precision on the job site, is to use what we call ground control. And ground control can work a number of different ways. One thing we can do with ground control is use ground control as a means of visually tying where the drone is in the sky to a specific location point on the ground. We can either do that visually, in other words, we identify a spot on the ground and we can tie to it, or better still, we're going to use a base station such as the one that you see here on the right-hand side of the screen, and we're going to capture very precise points. This is standard survey equipment. And this allows us to, instead of coming through and visually tying that point to where the drone is in the sky, we take the data from the base station, we put that into Pix4D or whatever other tool that we're using to precisely pinpoint where that image in the sky is located down on the ground. And this will tie us together. But laying in GCPs is not enough. We want to be sure that our GCPs are no further apart than 1,500 feet. When we lay them out, we want to lay them out kind of like the 5 side of a dice. We'll look at a picture of that in just a moment. We want to randomize these GCPs throughout our flight area, and we generally want to stay away from the edges. unless we're dealing with multiple date flights and we need to cross one data set into another data set to merge them together. We will need to have our ground control points visible in both data sets, or rather both flight sets that we have. We need to be sure that our targets are large enough for us to be able to see them at our chosen altitude of flight. One of the worst things that can happen is you lay down some of these really small GCPs, and you can find them on Amazon, for example. They're 6 to 8 inches in size, and they work really well if you're not flying any higher than 100 feet. But anything higher than 100 feet, you're going to need a fairly large target. So in this image you see off to the right here, you see a set of 18-inch sprays in there, and these are really easy to put in. There's also ground control points that we can pick up from Hoodman and lay down on the ground as we need to. So this is generally how we're going to lay these out. So in this particular case, this is going to be one flight. You can see that in total we've got 10 ground control points out. Now this is a good time to mention that having a whole lot of ground control points is not in your best interest. Generally, depending on the size of the site, generally 5 to 10 ground control points or GCPs is about all we need. If it's an extremely large job site, we've got something that's spanning out over several hundreds of acres, or if we've got a corridor scan that we're doing, we've got several miles to go through, then we might want to add a few more. But at the end of the day, we really just need to have not more than 10 ground control points. It's okay to use some of the ground control points as actual survey targets or marker targets, and then use others as checkpoints just to check your work and be sure that you're on target. But one of the other things that we want to consider, especially when we're doing this kind of work, is where we can, we want to have our base station as exposed to the southern exposure, or the southern sky, as we can. Here in North America, with where our hemisphere lies, or I should say our continent lies, we're going to get the majority of our information coming in from the south. So the cleaner exposure we can get to the south, the better off we are. What do I mean by that? Well, if you've got a building that's on the southern side of your operation, let's not put our base station very close to that building. Let's move it off to the side so that we've got better exposure. Even if it's in between buildings, it's better off than having it sit in front of a building, or trees, or hills, or dams, or any other kind of obstruction that's going to block that signal from coming into where we are. Also, if we can get that base station up at a higher point, it certainly does help. We're going to have to offset for that a little bit later on, but at the same time, the more satellite signal we can get to that base station, the better off we are. Now, not all drones are designed for mapping. So, for example, some of you may have tools like the Mavic lights that are out there, or maybe you've got some of these things like the Autel minis and some of these different types of aircraft. They're not designed for mapping. They can be used for manual mapping, but most of them don't have any kind of automation. There are predominantly two camps in the world of mapping solutions. There are some that are using open source and using mapping software tools that apply pretty well across the board, and then there are others that are proprietary. An example of proprietary mapping would be DJI or Autel. Many of the drones that are out there today are using a drone platform called QGC to program missions. It's Q Ground Control. And this is being licensed and used by many, many drone platform manufacturers out there, such as Wingtra and Microdrone and a few of the other, MapTech, a few of the others that are out there. This is non-proprietary. There are many different kinds of libraries, and this can be set up to be used in many different types of drones. So it's quite common. If you're using a DJI product, of course, DJI has their own automation, but if you'd like to use something that's a third party that might have a little bit more robustness in its features, you can certainly look at tools like the Litchi application for your mission planning. And in these mission planning tools, this is where we're going to set up things like our flight altitude, which sets up our ground sampling distance. This is going to allow us to set up our regions of interest, areas that we want to focus on. It allows us to create corridor-based missions. It allows us to create survey-based missions. So we'll look at a couple more of those in just a moment. Winds are an important factor when we're mapping. Now, it's important that we understand what winds aloft are and how winds aloft work. There's a number of different ways that we can get winds aloft. Off to the right-hand side here, you see a screenshot that comes to us from UA Sidekick. UA Sidekick gives us a feature called micro weather. This is weather in a 500 by 500 foot profile. So here we can see that we've got winds coming out of the south-southwest at 3 miles per hour. Gusts are 4 miles per hour. We don't have much cloud cover. We can see we've got 10 statute miles. So the tool actually gives us information that's pertinent to our flight to decide if we can be safe. There is no safe flight speed for mapping. In other words, if you're going to map with something fairly small and lightweight, let's say the Parrot Anafi, you're going to be limited to winds that are sub 20 miles per hour. If you're flying with something a little bigger, such as, say, the MapTech or maybe some of the Inspired Flight systems, we're just good to go all the way out to about 35 miles per hour of wind. If you're flying with a fixed wing profile, such as the Wingtra, you're going to be flying your aircraft at just a little bit over 30 miles per hour. We don't want to be in winds that are any higher than 40 miles per hour. It's not so much the flight where this drone is challenged as it is in the landing. So ground speed is pretty darn important when you're dealing with fixed wing systems or VTOL systems. So how do we manage wind? Well, the first thing that we want to do to avoid stacked wind images is we always want to fly at a diagonal angle to the wind direction. So in other words, if you can picture in a drone like this one, I'm going to set this up so that the wind is coming towards one of the arms on my drone. What that means is that as we're flying that drone forward, it's not flying into a headwind, and when it's flying the back direction, that's receiving a tailwind. That's what we absolutely want to avoid, because if we've got headwinds and tailwinds, it leads to what we call stacked images, and we absolutely want to lose that. So let's try and get the wind flying off to the beam of one of the arms on the drone, and that way, regardless of which direction it's going, the wind pressure is identical on either side of the drone in either direction. Now, the other thing to do is, in this particular case, we've got a housing subdivision here that we've been hired to fly. There's a small cutout area right here you can sort of see in this cut. And normally, we would cut this out, but this particular area on this particular day, we're flying in about 28 mile per hour winds. And so rather than creating small, odd-shaped cutouts, or what we call keyholes, we remove as much turn in the drone as we possibly can. Otherwise, what will frequently happen is, again, we'll see some stacking occur at various parts of that as the drone is turning mid-flight, and we want to avoid that as best as we possibly can. So yes, you will get a few extra images when we don't cut out some of these small keyhole areas. If you can cut them out and there's no wind, hey, that's great. But sometimes the environment isn't entirely cooperative with what it is we're trying to achieve. Now, I've mentioned stacking images a couple of times. Let me show you what that looks like. So this is a mission that was flown with a unique H520, and this was flown in fairly high winds. The winds were blowing at about 38 miles per hour. You'll notice that up here, the top part of the map is fairly sparse and there's lots of gapping in between the images. Yet down here, images are very heavily stacked. So what this means is, as the drone was flying in the northbound direction, it had a lot of headwind, but when it was flying southbound, it had quite a lot of tailwind. And so it was capturing pictures down here unevenly in the bottom end of the area that we were flying. Now, that doesn't mean that it's unusable. In this particular case, this was flown by a new pilot, sent this over to us asking us if we could help them fix this at all. Fortunately, we were able to, because we were able to identify things on the ground that allowed us to tie pictures from the air to specific locations on the ground using what we call manual tie points in Pix4D. So in the upper right-hand or upper left-hand corner here, you can see the initial point cloud that was created by that. And down in this end down here, we can see some real messiness. That's from those stacked up images. Same thing here. So the area that we were looking to capture came out pretty good. That's this area right here over top of the flat work, the pads that you see right here where these homes are being built. And then down here, we can see where some of that stacking was occurring in the initial shot. This is something that we absolutely want to avoid. Now, in this case, we got lucky and we got a clean enough image that we were able to lay the building plans right over top of it. So here you see the blueprints that are on there. Now, in this particular shot here, what's kind of interesting is where this is circled in red. When we flew this for the contractor, and we laid the plans over top of it, it became immediately noticeable that there was a section in the concrete work that did not match up with what was indicated on the blueprint. So in other words, the as-built didn't quite match the plans. And it turned out that a sewer stack had been poured about 8 inches out of alignment from where it should have been in the plans. And fortunately, they discovered this early enough before they started going vertical with the project. They were able to jackhammer out the concrete and move forward from there. There's another piece I want to mention here as we're starting to run out of time. as we're flying our mission, we're capturing all these individual images with our drone that are going to be assembled into a larger orthomosaic map, or sometimes into a 3D model. Is we can still use each of these individual pictures that we're capturing for points of inspection. So if we need to go see something at full resolution, bear in mind, and in Pix4D, this is going to be found on the right-hand side of your screen, bear in mind, we can always go and look in deep detail at what's happening in the scene with the actual photograph, as opposed to just simply looking at the larger orthomosaic that we've mentioned. So I'm going to show you a map that we have here. This is a helicopter crash scene that occurred out in Pioche, or just west of Pioche, Nevada. And what you're seeing here is imagery from the sky. We can't really see much down here on the ground, but in looking closely, we started discovering some small pieces of fuselage, some fiberglass, et cetera, that came off the helicopter that crashed. Well, this next image down here, what I've done is we've identified that same location, and here we've gone in and looked at an actual picture from the inspection side of Pix4D, and we can see a piece of that fuselage that was located down here in the base of the mountain, and that became fairly important to the overall investigation. So there's quite a bit that can be done with this. We'll talk about some of the other tools that are available in our next mapping session. In this particular session or indication here, you can see where we laid out a sky ruler for scale, and we've got some ground control points that you can see here in the image scene. So this particular project was really large. We had a lot of data that we had to put together, but we were able to take all this data over 77 acres and 7,000 images and tie them together using the ground control points that we just spoke about. So we're going to be covering quite a bit more in mapping classes or mapping information as we go through the coming weeks here, because this is one of the places where we get a fair number of phone calls or emails from people saying, hey, I was doing this with my map, but I ran into a problem. What would you guys do to make this problem go away? And we're very happy to answer those questions, but we're going to try and put more of those into our Lunch and Learns. These Lunch and Learns occur every Thursday at noon Pacific time. We're grateful to those of you that come and meet with us every Thursday and hear what we have to say or what we have to share. And of course, we do always put these up on our local YouTube page. Now, also, while we're looking at this particular slide, wanted to remind you folks, we've got an interactive PDF pre-flight checklist that you can use on your Android or on your Apple iOS device. You can also use it on a computer, but it is designed to be used on a cellular phone or tablet. If you just want to drop a note to us at myhelp@the-LiDAR Pros and say, hey, I'd like your free pre-flight checklist, post-flight checklist, send it to me. We'll email that right over to you. We'd love to engage with you more. So that brings me to the end of today's Lunch and Learn, or gives us time for a couple of questions here. I see I've got about 2 minutes if any questions are coming our way. I haven't seen anything come through on the chat channel just yet. You might want to be ready to check us next week, where we're going to get into RTK and PPK workflows with Ben Goddard. That's the next piece in this mapping series. So we'll look forward to seeing you next week at our next Lunch and Learn. Folks, thanks for spending this afternoon with me. We'll look forward to seeing you next week. Bye for now. Be safe.